Being a successful entrepreneur or leader doesn't mean you have to run on fumes. Dr. Andy Melton's Strategic Rhythm Reset helps high performers redesign their week so they can achieve more with less stress. During a 90-minute session, you'll dive deep into protecting your priorities and focus on your energy. You'll receive a personalized blueprint that balances business goals, relationships, health, and personal priorities. Afterward, a rhythm reset guide will summarize your insights and provide tools to keep you aligned, and a follow-up call ensures you stay on track. The benefits? Clarity on what truly matters. Freedom from overwhelm, better performance with less stress, a repeatable system, and momentum for long-term growth. Ready to reclaim your time and energy? Visit scalinguph2o.com/Andy Melton. Once again, that's scalinguph2o.com/ANDYMELTON. Don't wait, book your Strategic Rhythm Reset with Dr. Andy Melton today. Your system deserves the best, and so do you. Thermal Fluid Technologies brings you Protocol Heat Transfer Fluids. Formulated with their innovative no-pit inhibitors designed to keep your systems efficient and corrosion-free. Whether it's HVAC, food processing, or beverage applications, their glycol-based solutions deliver reliability where it matters most. Plus, with their comprehensive coolant testing program, you can rest assured knowing your system is always operating at its best. Discover the difference by going to scalinguph2o.com/TFT. Once again, that's scalinguph2o.com/TFT. Thermal Fluid Technologies, where performance meets peace of mind. Welcome to the Scaling Up H2O podcast, the podcast where we scale up on knowledge so we don't scale up our systems. I'm Trace Blackmore, the host of the Scaling Up H2O podcast. And Nation, I love hearing back from the Scaling Up Nation. And it's no secret, I have been challenging you lately to rethink the way that you think, rethink the way that you think that you know things. And so many people are letting me know that you're doing that very thing. You are running that test the exact same way that somebody showed you, or the video that you watched, or the instruction manual that came with your test, and you never thought about it. And you just kept doing that over and over and over again. And somebody wrote in to say that they downloaded the Hawk Water Analysis Handbook, and they were specifically looking at that specific test, and they found out all this information about interferences. And they then started thinking, am I getting an interference? How would I know about that? And then they started doing some things differently to help with that interference, and they got a different answer. Turns out they actually did have an interference, and they didn't know about it because they kept doing the test the same way that they learned it. I don't know how long it was that they learned it, but however long it was, they kept doing it the same way, and they never knew that they had an issue. So they were simply writing a number down, going on to their next test, going on to their next act of service in that account. Now, because they know that test better, that test has now become a tool that they can use, that they can predict what they think the test is going to do or not do, and that's going to strengthen whatever they think their hypothesis about that system is, and then they're able to act on it. Well, how long were they not getting the best information? And now, because they understand their test, they are able to get better information so they can better test their hypothesis, so they can leave that account better than they found it. And after all, that's our goal. When we get there, are we making sure that because we are there, we are making improvements and we are leaving that facility better than we found it because of all of our tools, like our tests and understanding our test. Our biggest tool is our ability to understand the systems that we are charged with treating with, and tests are just one of those tools that we use to do that. So thank you so much for that Scaling Up Nation member calling out to me on scalinguph2o.com, going over to our ideas page and just sharing a little story with me. I really appreciate that. And I'm hoping you're doing the same thing. How well do you know the things that you're doing? And when I say that, how well do you know the why behind the things that you are doing? Do you really know what's going on when you put juice A with juice B and then titrate with juice C? Well, if you don't know the chemical reactions that are going on. And in most cases, that's fine. But if you are trying to excel, if you are trying to really understand what's going on, knowing those chemical reactions allows you to know the other possible reactions that could happen inadvertently that doesn't give you the best answer. For example, do you know if you are testing sulfite in a boiler and you have a non-cooled sample, you will think you have a lot less sulfite than you really do. And then maybe you start turning up the sulfite pump, and that's now using all your sulfite, which is making that account more expensive, which is putting more solids into that boiler, which is meaning you're going to need to blow it down more, which means that you're not only blowing down water, you're blowing down heat. You're not only blowing down water, you are blowing down returned condensate, which is liquid gold. And there's just this train of travesties that continue to happen, all because we did not properly run the procedure properly. And in that case, that's knowing the procedure. And I'm asking you to go even further and understand what it is that your tests are doing. When you understand and not just know how to do, that turns you into a completely different type of water treatment professional. Now it's all about your knowledge, and those tools that you're carrying around aren't just a task that you have to do, they are enhancing your knowledge, not only what you know, but what you know of that system, and they allow you to take better action on what you are going to do next. So once again, that was a story somebody shared with me. I'm being a little vague because they shared some personal things with me, but the point of the story is they're actually doing the things that I am asking all of you to do on this podcast. So when you try something, if it's working for you, let me know that. I love to know that. In fact, if it's not working for you, let me know that too. And maybe there's something that we can do on this show to help you out with that. You know, somebody that's always trying to help us out to become better water treaters and to have fun in the process is our friend James McDonald. And here is a brand new Words with Water.
Hello and welcome to Words of Water with James, the industrial water game show where I give you the definition and you get to guess the word or phrase being defined. Will you rise to the top or get blown down to try your luck another day? There's only one way to find out on Words of Water with James. Today's definition is the smallest functional unit of a cooling tower that contains its own heat exchange section, fan or air moving system, water distribution system, and drift eliminators. Can you guess the word or phrase? The answer is a cell. Okay, for those who got it correct, step to the right. What? No one got this one wrong? Good for you. Wait, I see you hiding back there. Come on over. I'm James McDonald, and I look forward to seeing you next time on Words of Water with James.
Well, thank you, James. And Scout Up Nation, I do want to thank all the people that have given me feedback about this podcast, like the person I just referred to in the introduction that let me know they tried something new and it actually improved the type of service that they were providing at a particular account, probably at all of their accounts. I know we're doing the right things when you all are giving me feedback. And a couple of years ago, we decided we were going to let you know what was going on in the industrial water treatment industry, because let's face it, with the calendars that we all keep, it is hard to know of all the conferences and different activities that are going on that allow us to up our water treatment game, but we may not know about it because we're busy doing our water treatment game. So with that, we decided we were going to let you know about conferences and trade shows and technical seminars that were going on. And we didn't know if that was going to be well received. Well, we've done that for a while. And the reason we've done that for so long is because I hear on a regular basis when I get to hang out with you at one of these conferences that a lot of times you learned about these conferences from the Scaling Up H2O podcast. In fact, I normally do a poll for the Association of Water Technologies technical training when I'm doing my training. Now, maybe I'm doing the introduction to water treatment course, or maybe I'm doing a math course, but I normally find some way to ask the question, how did people find their way here? And what I mean by that is, how did they know when and where this was going on, but then also knowing that this was a worthwhile event for them to attend? And 9 times out of 10, more than half the room will raise their hand that they heard about it here on this podcast. So that's why we do that. We want to make sure that you are in the know that there are a lot of things that are going on towards our industry, towards getting you to that next level in our industry. And we want to make sure that you know about it. So something you might want to know about is the Utility Management Conference taking place March 24th through 27th. And this is going to be held in Charlotte, North Carolina. Charlotte is a fantastic town. It's about 4 hours from Atlanta. If you've never been there, it is a great place. And that is being hosted by the Water Environment Federation. So we're going to make sure to have all the details on that show for you. And if that's something you want to attend, we're going to make it really easy. All you have to do is click on it and it will take you directly to that page, so you can make all the arrangements that you need to. Another show you might want to look into is the American Boiler Manufacturers Association is having their 2026 Expo in Nashville, Tennessee. Now, this is going to be March 31st through April 2nd at the Gaylord Opryland Resort and Convention Center right there in Nashville, Tennessee. Now, you might remember back on episode 422, I talked to former AWT president John Caloridis, and he mentioned to us that we were doing, and I say we, the Association of Water Technologies, were really doing a better job with working with the American Boiler Manufacturers Association. Now, I think AWT might have a presence at that show, but you'll know for real if you go there. And of course, we'll have all the information for you to make those reservations simply by going to scalinguph2o.com and going over to our events page. And while you're there, check out the 2026 Water Quality Association Convention and Expo taking place in Miami, Florida, April 28th through April 30th. And we're going to have all the information on these 3 shows that I mentioned, as well as everything else that I didn't mention, simply by going to our event section on scalinguph2o.com. And you will learn that there is just so much going on. I hope you take time to open up your calendar and figure out what you're going to go to this year. You know, Nation, have you ever thought about the infrastructure that gets the water from the municipality to your faucet? Of course, we're industrial water treaters. We think about that stuff all the time. but most people do not. Now, we know a lot more about water and how it gets delivered to us because of what it is that we do. But here's something you might not know. In a study done by the EPA back in 2023, they found that over 9.2 million lead service lines are delivering drinking water to our homes and buildings. That is a lot of service lines that contain lead in them. And you might be wondering, okay, if we have this lead issue, if we know that there are some health concerns with lead, why did we ever use lead in the first place? Well, probably the first and foremost reason is it was a very soft and easily formed. Very simply put, lead is malleable. So pipe fitters could very easily manipulate this material around obstacles and connect it to other pipes without it cracking. The other thing is it was very malleable. So as the ground shifted, as roots grew, it could actually kind of mold itself around that. Not always, but in most cases, it was able to stay non-leaking more than other materials. And it's also resistant to corrosion in appearance compared to iron. Now, there's some other corrosion that we have to worry about there, but if you compare it to iron, there are all these really good reasons, including it was very low cost and highly and readily available. So in the 19th and 20th centuries, when they were putting all this infrastructure and they had very limited understanding, as we now know, as far as toxicology in today's studies, they just didn't have that information back there. So now we do have that information. And now the question is, okay, why don't we replace all this? Well, also in that study that I mentioned, they estimate, and this number is staggering, they estimate that roughly it would take 28 to 47 billion US dollars to replace all of the infrastructure in the United States that has lead in it. $47 billion. That's a number I can't even think of. But that is what they say it could take. And of course, that's what's driving the non replacement with this. So that means that when it comes to corrosion, when it comes to lead leaching out, we need to be on top of our games. We need to know what's going on with that. We need to know all the things that we can. And that is where our next interview comes in. I have not one but two lab partners today, Pat Rosenstiel and Wolf Merker of Great Water Tech. Welcome, gentlemen.
Thank you.
Thanks for having us.
Well, I want to make sure the Scaling Up Nation knows who we are talking to. So, Wolf, do you mind introducing yourself to the nation?
Yeah, hi. I'm Wolf Merker, chemist at Great Water Tech. They like to call me the chief science officer, make me look fancy, but I'm really just a chemist. I've been in water for 13 years now, water chemistry. Did a few things before that, made lotions and shampoo for a while.
I got to ask, which is a better gig, water or shampoo?
You'd be surprised to know that it's all about water.
Pat, how about you?
Yeah, well, my name's Pat Rosenstiel. Live in St. Paul, Minnesota. Grew up in Whitefish Bay, Wisconsin, and I'm chief executive officer of Great Water Tech. Been in the water business since I learned about some of the corrosion problems in Flint, Michigan. Didn't realize how extensive those problems were. And then talked to my buddy Wolf about it, who had some experience with a product out of Germany called Fomar, which I think we'll talk a little bit about today. I definitely respect chemists and think Wolf undersells the chief science officer part of this, because without science, we'd be nowhere. That's what I'm here for today. Is I've always been a problem solver, and I got into the water business to solve some what seemed like pretty pressing problems, and have been hanging out with Wolf for, a couple of restarts a little bit before COVID. Then there was COVID, and then restart after COVID, and, had my shoulder to the wheel that way on the water issues that I care about since.
Well, Pat, maybe you can tell us about that story. So, we all heard what happened in Flint, Michigan. You heard that, and what did you do?
Well, I pay attention. One of my first careers was around regulated industries and American politics. And so, I pay attention to things, back in the early aughts. It was lessen our dependence on Middle Eastern oil during the Gulf Wars and stuff like that. And, learned how to do some problem solving there because I had a friend who shot some 3G seismic that became the Bakken Shale. Northern Oil and Gas was one of the first players there. And so, when he shot the seismic, I knew about the problem, which is, oil over $100 a barrel, which isn't good for anybody in the country. And he understood the geology and he understood sort of the operation model to get the oil out of the resource so that we could drive down the cost per barrel. We commercially got involved and figured out how to solve that problem. And some of that's about regulatory environment. Some of that's around tenacity and capital and all those other things that you need to solve problems. So when I read the story about Flint, Michigan, I was like, it did not make sense to me that in, what I believe is the most important, largest economy in the world, we can't figure out how to get lead, copper, and corrosion-free water to American consumers in a city the size of Flint, Michigan. That made no sense to me. At the same time, Wolf was talking to me about some water technology found in Germany that he can explain better than I can from a scientific standpoint, but that at first was treating water towers, and that he was thinking about starting a company called Great Water Tech to import those technologies to deal with corrosion issues in the drinking water system in America. And I was like, well, okay, that's interesting because I'm trying to figure out how to do that myself. And then I think, we connected over a couple of meetings, and what was born, he conceived it. I think we've birthed it together, which is Great Water Tech. And we still remain interested in solving those very real problems around corrosion. We also have other technologies that deal with algae in the green water environment, in the drinking water space, obviously, but also I'm concerned about overgrowth of algae polluting our lakes and ponds. So it's become a passion project of both of ours. And, that's how I find myself on your podcast here today, talking to the nation, which I love. I love that you call it the nation.
Well, we're glad that you're here. Wolf, when you think about what happened at Flint, Michigan as a chemist, what are your thoughts? And maybe can you explain to the Scaling Up Nation what was really going on there?
Yeah, we have to separate the technical problem from the political challenges. From a technical side of things, I would say it's not so difficult to solve these matters. In the case of Flint, what happened was they changed the source water for the system. And by changing the source water, they ended up with a different level of corrosivity. And they didn't proactively implement solutions for that. And because of that, things started to corrode. Since then, the scientific standards have changed in terms of how we think about lead exposure. And like we say now, there is no safe level of lead exposure. So we have to remember, too, that our thinking around this has changed since then. So we have to be careful about assigning blame or things like that. But, ultimately, it has been a lot of years now. If I recall right, they ended up adding an simple anti-corrosive phosphates, and solved the problem that way.
So, if I recall back in the day, they would use lead piping because it was malleable, it would bend. And as things would shift, you didn't get a pipe break. Well, bad thing is, it's not good when you ingest it. So, I'm curious, do either of you know how much of the American infrastructure still has lead piping?
Nobody knows.
Yeah, that's it. Nobody knows.
Yeah, I don't know that we could way too. I wouldn't even say way too much of it. And I want to go back to what you both talked about, which is I wrote a piece, and I think it ran in the Duluth News Tribune. I live in Minnesota, and there's the section of their drinking water system. There is lead in their system. I think lead served a purpose, one of the most important public health purposes, frankly, in the history of, I don't know, civilization. It allowed us to get drinking water, you know what I mean, and water as a tool into households, right? So we have an infrastructure bill that passed that spent somewhere in the neighborhood of $600 billion to allow people to replace lead service lines, right? Well, you replace the lead service line in Duluth, and then you continue to have sort of the goosenecks into the home and then lead piping within the house. You know what I mean? Corrosion happens at the level of the basic infrastructure. And if you add all that stuff up, I think it's almost impossible to calculate the cost of delivering lead free water through pipe replacement. So I think there's a lot of people who did good work to lay the lead service lines to make sure that we had drinking water free of, I don't know, things that were making people sick too, right? Now, if we have the technology that allows us to treat corrosion all the way to the tap, which FOMAR does, to the best of my understanding, and certainly a proven track record in Europe and wherever it's been used here, we can treat all of the lead infrastructure, and that lead service line replacement is good. But it's like, okay, lead service line replacement, then what? Because when you think about the context of replacing all lead in America's drinking water system, you know, dealing with the service line is only the tip of the place that corrosion can occur. In order to replace all the lead in America's drinking water system, or copper, because copper corrosion is not good to ingest either, or galvanized, any of the things that leach based on corrosion can be mitigated through corrosion mitigation products like ours. And this isn't an ad, I'm just trying to tell the truth about our product. We have to treat the entire system, and to replace all of those lines would be like doing, I don't know, noise mitigation and airport footprints in every house and every piece of infrastructure in America, including, hospitals, businesses, homes. There's not enough money on planet Earth to deal with that problem.
So most municipalities use some sort of corrosion inhibitor. I think normally it's a phosphate. And they're trying to make it so there is some sort of tenacious film on the piping so they can reduce corrosion and we don't have problems like we were just talking about. So municipalities, if they are listening today, is that the best way to do that? Are there alternative things that they can consider?
Yeah, phosphates are a little bit of old news in the space, and they've been used a long time and they work to the extent that they work. I think what we're figuring out is that they're not working well enough, right? We still have the issues. So there have actually been strides made in the science of this in the last century. So there are better ways to go about it than simple phosphates.
Well, I would love to start the conversation there. What are some of the newer technologies that we can make everybody listening aware to?
Yeah, so our approach with our German partners has been a mixture of phosphates as well as silicates. So those are the two general groups of corrosion inhibitors. And what they figured out in Germany 40 years ago is that if you use them both in the right amounts, they work a lot better.
A synergistic approach?
Yeah. So the phosphates create a barrier as well. And we're trying to get this separation between the water and the metal. It's not a great barrier. And what the Germans figured out is that with this combo approach, you can get a really good barrier. And by doing that, you can get at multiple sources of corrosion simultaneously. So we have generally three main sources of corrosion. One is chemical. So it's the action of the water and whatever's in the water on the pipe. The second one is biological. So whatever's growing on the pipe or in the pipe is actually eating at the pipe. That's where we get a lot of pitting and stuff like that. And the third one's electrochemical. So we combine these pipes of different materials and we get dissimilar metal corrosion. And you can actually get at all three of these sources if that barrier you're creating is tight enough and electrically insulating.
Well, and at the practical level, what's interesting about this approach, and certainly case studies throughout Europe prove it out, is that the net effect of the formula, right, the blend, silicate and phosphate blend appropriately dosed based on water volume in the system, is that you get, in effect, what becomes an ultra hard, ultra thin nano barrier system wide from the end of utility all the way to the tap, right? So it treats the entire infrastructure with what, in effect, becomes a nano barrier. And I think it's amazing that it stops leaching, you know what I mean, and corrosion. So you can deliver water to the tap that not just meets the new lead and copper standard, but exceeds it, gets you closer to zero. And if I said zero, Wolf would correct me because he's convinced me there's no zero in chemistry. But I mean, basically, you're exceeding the standard at the tap, which is not happening in the ortho systems. I mean, or the phosphate systems. We know that based on the news clips we get on a regular basis. And I'm not here to attack that solution. But what's really incredible about this is I think it's the only product on planet Earth, because nobody's convinced me there's another one that can allow you to exceed that new lead and copper rule, that creates a smooth barrier in which you can deliver your water, right? So it improves your CO2 footprint, right? Or your carbon footprint, which is good because you get energy savings from the seamless transition of water. And then I think in a lot of important ways, it seals leaks and cracks before they become gaping holes in your system, which cuts back on your need to, I don't know, replace pipes, which is a good thing. But more importantly, it reduces your non-revenue water loss. So every water utility manager I talk to, it's like, well, if you believed that we could help you exceed the lead and copper rule at the tap, if you believe that we could improve your energy costs, if you believe that we could cut back on your non-revenue water loss, and if you believe that your chlorine levels would hold consistent throughout the system, cutting back on disinfectant byproducts, would you adopt a product like that? And I think it's only a matter of time before many water utilities take us up on, yeah, that sounds like the kind of product I should try.
Well, if I could, let me ask you about a couple of items that you just mentioned. One, you said it helps create a smooth barrier. So the assumption there is it's actually cleaning up the corrosion that's in the lines. Is that fair?
I'll take that one. So corrosion and scale buildup in water systems, and they're related, but they're also different things. And what we do currently to address scale buildup, which creates these restrictions, it's called pigging. So you basically take some type of solid material and you force it through the line and you open it up. And once you do that, if you're using a proper corrosion and scale inhibitor, you don't need to do it again. So that's really, I think, what Pat's getting at there. And I'd like to also mention what Pat's saying gets to this point of cascading downstream consequences. And there are many of them. He mentioned chlorine residual loss, for example. So how do we deal with that today? The standard solution is that you switch from chlorine, which is really just bleach, to chloramine. And when you switch to chloramine, you're increasing the corrosivity 40 times. I'm not into solutions that cause new problems. We want to be able to stick with chlorine, and people might not like it, but they also don't realize that you can't actually smell chlorine in water. What happens when the chlorine reacts with whatever's there, the dirt, if we want to just put it that way, and the resulting products is what you smell when you walk into pool space, right? It's not actually the chlorine. And so chlorine at the levels that they're used in drinking water, when they're successfully used, it's not harmful. It really does help a lot, because we really don't like the gastrointestinal problems that can result when you don't have the disinfection, right? And that's just kind of one rabbit hole to go down. The disinfection byproducts, I kind of mentioned them, right? So you're using chlorine, it reacts with this stuff. Now you're getting chlorinated hydrocarbons. And if you start looking up what those are, you're going to find some of the most toxic things on planet Earth. So there are these downstream cascading effects from corrosion that really affect the quality of water at every level.
I would ask one clarifying question, Wolf, though, is that the nanobarrier itself, in effect, that separates water from pipe, and that creates a smooth system with which to deliver water, where water utilities would expect an energy saving, that they would use less energy to drive water through the system, and that would provide energy savings through a silicate phosphate blend.
So the barrier is super thin. It is smooth. It's not going to smooth your pipes out for you. What's there is there. And you're going to have to do this pigging. I don't like the word, but you're going to have to pig them one last time in order to improve that energy efficiency. So yes, it will maintain the smoothness that you have. You won't get additional restriction over time. And once you deal with whatever restrictions are there, you stick with a smooth and thin barrier.
And I just want to confirm one other thing I said, right? Because it's part of the value proposition of a silicate phosphate blend. That phosphate does not necessarily deliver or does not deliver. I'm curious for both of us that the scientist agrees that one of the benefits of adopting a silicate and phosphate blend as opposed to just going phosphate is that it seals in a more effective manner small leaks and cracks, which does drive down non-revenue water loss. And every system that the silicate and phosphate blend has been used has seen significant reduction in flushing, which I do not believe is an inconsequential fact of silicate phosphate blends versus the traditional or incumbent technology for treating these problems with just phosphate in America. Is everything I just said, is that overstated, or do you view that to be true?
No, that's entirely true.
I just have to check with the experts sometimes to make sure, because I mean, the bottom line is one of the reasons I got so involved here is because I am absolutely fundamentally interested in addressing the problems in America's drinking water market in the most efficient way for the water utility managers who do a great job every morning waking up, trying to leverage the best technology to deliver the best results for their customers. Like, I believe that to be true. But I want to make sure that we're talking to the nation about why, when you're looking at a product that is a silicate phosphate blend at the right formula that's totally tested and proven, that is NSF 60 certified, that there are sort of benefits to adopting this product that are way beyond what the incumbent solution can deliver. And frankly, when, I don't know, federal governments are appropriating $600 billion to address these problems, I think it's incumbent. And then the state and locals are matching their investments. I think it's incumbent for every water utility leader, manager, thought leader to understand that for pennies per user per day, now that the standard has moved to the tap, we believe that silicate phosphate corrosion treatments are the future that allow you to meet the new lead and copper rule at the tap, no longer the hydrant. And frankly, if you know that, if you try that, if you are failing at the tap, we'd love to hear from you. Because in the end, you now know, if you listen to the nation, that this solution is available, at which point there's a risk to not using the best products in some ways now.
Before we dive deeper into our interview, we're going to take a quick break to hear from one of our sponsors. Hey there, Scaling Up Nation. It's Trace Blackmore here with a shout out to all the hardworking water traders out there. You deserve a partner who's just as dedicated as you are. That's why I want to introduce you to my friends Sarah, Drew, Dave, and the rest of the crew at North Metal and Chemical Company. North Metal isn't just about delivering high-quality chemicals. They're about delivering exceptional support from experienced professionals who understand our industry inside and out. Their unmatched service means they're ready to ship your Northwest brand chemicals when you need them, no matter the challenge. With their commitment to small businesses and long-term partnerships, North Metal and Chemical Company is here to help you succeed every step of the way. Visit scalinguph2o.com/north today and learn how they can support your water treatment goals. Once again, that's scalinguph2o.com/north. North Metal and Chemical Company, serving the water treatment industry since 1921. Let's jump back in right where we left off. Gentlemen, let me ask, who are your customers? We have primarily industrial water treaters listening to this podcast. So what do you want them to know? How can they help the cause?
I can take the first stab at this, which is industrial water treaters are different than water utilities, right? And the good thing about Fulmar, like if I know anything about industrial water treaters, they're into CapEx and OpEx. Am I right or am I wrong about that?
Yeah, I would say that's fair.
Yeah, so as a business guy, I'm into CapEx and OpEx. They're into extending the life cycle of their closed water systems. If I understand the industrial water market, it's like, what can I do to preserve the utility of my equipment and extend the life cycle of my closed water systems to improve my CapEx and OpEx? And I would say that Fulmar is a perfect anti-corrosive that can extend the life cycle of your closed water systems because it's probably the best at doing that in a utility water system, right? So I would say if you're in a closed water, hard water, you know what I mean, environment, that anti-corrosion is all about how do I extend my need replace equipment? How can I maintain it in a way that maximizes the life cycle of my closed water system? And I think Fulmar or silicate phosphate blends, the only one I know a bunch about is Fulmar, is a very good product for that. But I would love to hear how Wolf answers it.
Probably with more words. So a closed water system is a little different from an open water system. And the difference there is an open water system goes to a tap that goes to a drain. A closed water system is like, for example, a pressurized boiler system or something like that. The best approaches are a little bit different, but regardless, the concept of combining silicates and phosphates remains the best approach that I'm aware of. So we have a different flavor of Fulmar for a closed water system, but really this fundamental approach is the best way to do it that I'm aware of.
So, for example, an industrial water system, that would include a large HVAC system or it would not?
Yeah, primarily maybe a cooling tower, maybe a closed chilled water system, something like that.
Is the product recommended, for example, is the silicate and phosphate blend, Fulmar is operative in those environments, correct? It's helpful in terms of extending the life cycle of the equipment, or like talk about those specific environments.
I don't want to overcomplicate it. I'm just going to say we have different flavors of Fulmar for these different systems. It's not so easy that one solution fits all. But whether we call it Fulmar or Fulmason, or the basic approach is the same.
Well, if I could clarify with what are the different products or industries that you guys are serving? So it sounds like an HVAC system, you guys have a product for that. For the municipal drinking water system, you guys have a product for that. Anything else you want to add?
Yeah, we have a lot of products that we have access to through our German partners. I think maybe the main one that we're working on right now is it's called Algae, and is a nutrient binding technology that will assist in controlling the overgrowth of green species. I have to be a little careful how I talk about this, because if you talk about certain things in a certain way, they get regulated differently.
Understood. With that being said, if I was a golf course manager, is that a product that I would want to be looking at?
Yeah, that's actually where we did our initial pilots. And the idea that this might be a product that we really need came to me as I was flying back to Minnesota one day from Germany. And I kept seeing these golf courses where I couldn't tell what was the pond and what was the green. And I remember our first conversation. This is a lot of years ago now. And Pat's like, well, they don't have any funding to deal with this. But it turns out they actually do. A lot of effort is spent trying to deal with this in different ways. One of the approaches is to use pesticides to just try to create an environment so toxic that these green things don't grow. Our approach is kind of the opposite of that. It's let's try to get the water clean. Let's try to get the environment such that things don't want to overgrow, rather than poisoning them out of existence.
So, do you all work with the customer directly? Should our listeners contact you if they have customers that are looking for the solutions you offer?
Yeah, I would say the best thing to do is contact us directly at greatwatertech.com. Depends on the problem they're working on, right? What we do is tailored solutions, I think, is what you're hearing. I mean, we're not in the service business, but we need to learn a lot about the problem you're trying to fix or the opportunity you're trying to seize. And then we can either point them to a distribution network on the green growth side of things or applicators that we work with there. We can ship direct to customer and work with them based on volume of water they're treating in their closed water, in some cases open water environment, or in all cases open water environment too. So I think the best thing to do is to call us, and then we point them in the direction of whether we deal with them directly or hand them off to one of our distribution partners who understand the product, and then we support our distribution partners.
We'll be sure to put your contact information on the show notes page for this episode. So, Wolf Merker, Pat Rosenstiel, thank you so much for coming on the Scaling Up H2O podcast.
Well, thanks for having us. We're grateful to be here.
Yeah, thank you very much.
Well, Nation, I hope this interview gets you thinking a little bit differently, as all of our interviews should. Now you've got some resources, you've got some more information. So if this topic ever comes up or you are talking with someone, you can now guide them so they can get some more and some better information. And of course, our fine guests, they have a product around this. I encourage you to look into that, but also look into the chemistries, why things work, just like that test kit we were talking about in the very beginning. When you understand the reactions, heck, when you understand the reactions, you know exactly what happened in the Flint crisis. And unfortunately, that's what happened because there were chemical reactions. And when people made some choices, they weren't necessarily thinking of those chemical reactions, or they weren't keeping up with the different changes in makeup water, so they weren't keeping up with the potential chemical reactions that happen. So it's my hope that that is how you are thinking. And whenever you put anything into water, water is the universal solvent. And water, against anything else, eventually water will dissolve whatever that anything else is. And that is going to cause something. Do we know what that causes? And that's simply what corrosion is. So if you're an industrial water treater listening today, think about where corrosion control to the tap or through a closed system is part of your value proposition. So when was the last time you talked about corrosion to your customer? Maybe that's something you talk about each and every day. Maybe you just have a report and you say everything looks good. And if you don't learn anything from this podcast, please learn never to write everything looks good. If that was the case, the system can treat itself without you. There is always something that we can do to make that system better. There is always something to improve. There's always something we did that we didn't get credit for. And your opportunity to get credit for that is on that service report. So make sure that you are writing all of that down. And make sure your customer understands that you are trying to protect them because the water in their system will corrode all of the equipment that water is traveling through. Now, our job is not to eliminate that corrosion. Our job is to slow that corrosion down. And we talked about particular chemistries in today's interview, but that's what we're doing. We are putting chemistries into the water to slow down that corrosion so it can last longer. So that corrosive byproduct doesn't create a concern in some way later on down the line. So make sure you are always bringing in that the fact that you are here and that you are doing things correctly, you are making that system last longer. You are making sure that adverse situations do not occur if you were not there. I talked to an AWT member not too terribly long ago, and they were telling me that they actually calculate based on corrosion coupons and how much iron they have in closed loop systems. And then they also weigh their filters before and after on high iron fouled systems to say, how much iron is in their system. Now, they weren't able to tell me an actual equation that I felt comfortable using and sharing with all of you so we can all start weighing our filters and showing our customers, hey, what are we doing here? What are we pulling out of the system? Where is that coming from? That's coming from your pipes. But the fact that they are doing that, they are showing their customers something that a lot of us might not be showing, and that's that dirty filter. So you have a filter that goes in and it's super white, and then it comes out, maybe it's a bag filter, and it's got about 7 inches of crud, and maybe a lot of that is corrosion in the bottom of the bag when you take that out, and it's your service call. So your job is to change that filter. So you simply just throw that in the trash can, put a new one there, and you write on your service report, you change the filter. Well, nation, you got to get credit for this stuff. And also, you want your customers to know the value that you bring and all your suggestions, because you probably suggested for them to put that filter feeder on their closed loop system. You want to show them exactly what's coming out of that system. And now it's in the filter. And we know that water is a heat transfer medium. We know that crud is not a very good heat transfer medium. So we are physically going to show them what we are doing to enhance their system. Don't just throw it away, show it to them before you throw it away. Now, don't have a story like me. I actually this was early on in my career, I brought a bag filter through a pretty high-end lobby, and it wasn't a lot, but there were a few drips on the floor. I had put it into a cardboard box, which at the time, I was young, I thought it was fine. It was not. I had a couple drips I had to clean up. Again, it wasn't that big of a deal, but it could have been. So I make sure if I'm doing that, it goes into a plastic bucket now. So there you go. I'm sharing a life skill that I had to learn through embarrassment. Now you don't have to take that embarrassment. You can just learn through my embarrassment. The bottom line is get credit for your work. And when you can demonstrate how the things that you are doing are working to your customer, that is so beneficial when you go to them and you ask them to do another improvement. And you say, hey, remember we installed that filter feeder a couple months ago or a year ago? I'd really like to take this to the next step. And this is the next step. And these are the things that it can do, just like we removed all that dirt and debris from your system. Trust me, that will help you with your customers because they're now starting to understand what it is that you do. And it's not just this mystic voodoo that we do that nobody understands. Folks, there's a lot we can do in our explanations to help people understand. And I sure understand that you could listen to anything while you're servicing from account to account. And I am sure glad that you are choosing the Scaling Up H2O podcast. So thank you for that. Have a great week, and we'll have another episode for you next Friday. Until that time, take care. Collaborate and thrive. At the Rising Tide Mastermind, collaboration is key. Work alongside like-minded professionals who are eager to share insights and strategies. Together, we achieve more. Join us and experience the power of collaboration. To find out more about the Rising Tide Mastermind, go to scalinguph2o.com/mastermind. Once again, that's scalinguph2o.com/mastermind. Find out if the Rising Tide Mastermind is right for you.